Good day, juniors! Our lesson for today is ionization of water. In this video, we are going to calculate the hydronium and the hydroxide in a solution. And this is how we are going to do it. Step 1. Write the ion product constant of water or K sub W. Step 2. Solve the K sub W for the unknown. Step 3. Substitute the known hydronium or hydroxide and calculate. Are you ready? Sample problem number 1. Determine the hydronium for a solution that has a hydroxide of 1.0 times 10 to the negative 6 moles per liter, which is denoted by capital letter M. We have the given OH is equal to 1.0 times 10 to the negative 6M, and we are going to solve for the hydronium. Step 1. Write the product constant of water, K sub W is equal to the quantity of H3O times the quantity of OH is equal to 1.0 times 10 to the negative 14. So where did we get the value 1.0 times 10 to the negative 14? Experiments have determined that in pure water, the concentration of H3O and OH at 25 degrees Celsius are each 1.0 times 10 to the negative 7 m. When we multiply these concentrations, it forms the ion product constant of water, K sub W, which is 1.0 times 10 to the negative 14. The concentration units are omitted in the K sub W value. K sub W is equal to the quantity of H3O times OH, so that is equivalent to 1.0 times 10 to the negative 7m times 1.0 times 10 to the negative 7m, which give us 1.0 times 10 to the negative 14. Okay? So step 2. Arrange the K sub W to form the unknown. K sub W is equal to H3O times OH is equal to 1.0 times 10 to the negative 14. Dividing through by OH gives K sub W over OH is equal to H3O times OH all over OH is equal to 1.0 times 10 to the negative 14 divided by OH. From here, we can use the formula H3O is equal to 1.0 times 10 to the negative 14 all over OH. Step 3. Substitute the OH and calculate the H3O. H3O is equal to 1.0 times 10 to the negative 14 all over 1.0 times 10 to the negative 6. That will give us 1.0 times 10 to the negative 8m. Okay, so the value of the hydronium is 1.0 times 10 to the negative 8m. Because the OH of 1.0 times 10 to the negative 6m is larger than H3O of 1.0 times 10 to the negative 8m, the solution is basic. Sample problem number 2. A vinegar solution has H3O of 2.0 times 10 to the negative 3m at 25 degrees Celsius. What is the OH of the vinegar solution? Is the solution acidic, basic, or neutral? So we have the given H3O is equal to 2.0 times 10 to the negative 3m. And we are going to solve for the OH. The formula is OH is equal to 1.0 times 10 to the negative 14 all over H3O. So this is the solution. OH is equal to 1.0 times 10 to the negative 14 all over 2.0 times 10 to the negative 3. So that will give us 5.0 times 10 to the negative 12 m. Because the H3O of 2.0 times 10 to the negative 3 m is much larger than the OH of 5.0 times 10 to the negative 12 m. Therefore, the solution is acidic. Now let's see if you can do it. Please get a piece of paper, a pen, calculator, and solve for the following. Calculate the OH of each aqueous solution with the following H3O. Urine, 5.0 times 10 to the negative 6 m. NaOH, 4.0 times 10 to the negative 13 m. Ammonia, 1.8 times 10 to the negative 12 m. And vinegar of 1.0 times 10 to the negative 3 m. Practice exercises will be discussed in our synchronous meeting. Goodbye and God bless, juniors!